Hello guys, today we're going to talk about TensorFlow.js, how to install it and how to use it to create your first machine learning model in JavaScript. So the first thing I want to show you is actually the site of TensorFlow.js. As you may already know, TensorFlow is actually primarily Python library, but actually the main source code for TensorFlow is written in C and C++. So actually they created a bridge using JavaScript, so you can use TensorFlow from JavaScript, and it's actually pretty fast when you use it in Node.js. So you can use even trained or pre-trained model done in Python or Keras, in TensorFlow or Keras, and actually import them in your JavaScript application. Like if you're doing a React app or maybe Vue app or Angular app, you can actually use the pre-trained models right in your web app. The first thing you might want to try out is the tutorials and the guide. There are also some really cool demos. Okay, so you can take a look at those. And the last tab actually is the API tab, which is really helpful once you start actually using the library. Today we're going to use Code Sandbox to create a sandbox from scratch. We're going to use vanilla.js, so no libraries. We're going to create that sandbox. And then we're going to use the package manager to install TensorFlow. This is the main library, TensorFlow/tfjs. We're going to use that and add it as a dependency. Additionally, we're going to install some dev packages that are needed for our project. I'm going to go to the package manager. Let me just change the font. So you can actually see what is happening. 18 probably. Okay, I hope that this is fine. I'm going to go to the package and replace the dev dependencies, and the next thing I'm going to do is create a .babel.rc file and paste some content in. You don't need to actually remember this or write it right now, because the source code will be available down below. Okay, so we have the package, we have TensorFlow.js installed, and we have simple index.html file. And the thing that we're going to do right now is actually get started with TensorFlow.js. For that purpose, I'm going to import TensorFlow.js. Like that. Okay. Then I'm going to actually remove all of this and create an async function called run, in which we're going to do most of the tutorial. To actually run this function, I'm going to check if the document or the DOM is ready. And if it already is, I'm going to actually call the function, else I'm going to wait for the DOM to be ready and then run the function. Okay, just to try it out, I'm going to print something in here, and as you can see, the console is printing out the hello thing right here. Okay, so let's start with TensorFlow.js. The first thing I'm going to show you is actually this thing called Tensor. Tensors are, you can think of tensors as data containers. They can contain arbitrary dimensional n-dimensional data. What this means is like you can put in scalars, vectors, matrices, or any n-dimensional data you have. Tensors are used as data containers for your models that you're going to train and build. So all your data should be stored and will be stored in tensors, so that actually TensorFlow.js can understand what data you are providing it for training your models. Okay, so how do we create a tensor? One thing you can do is go to the API, and the first thing that comes here is the Tensors chapter in the documentation. And as it says here, tensors are a core data structure of TensorFlow.js. They're generalization of vectors and matrices to potentially higher dimensions. Okay, and here are some examples how to use tensors. What we're going to do is actually create our own tensor, a simple vector, and we're going to do that using, I've imported that as tfjs. I'm going to import it as tf only. Okay, so from tf I'm going to call the function called tensor, and I'm going to pass in a JavaScript array. So this is your first tensor. This tensor is actually a vector since it's one-dimensional, and there are a few things that you can check on this vector. You can check the dimensionality of it. As you can see, the dimensionality is called rank of the tensor, and that value for now is 1. So yes. Okay, the next thing is actually checking the shape of the tensor, and the shape is actually the size of each dimension. Since we have a single dimension right now and 3 elements in it, we have simple an array with one value of 3. So the next thing that you might want to try to do is actually print the values of your tensors. And one thing that you might find confusing is that when you try to console walk your tensor, you might actually not get the data that you want. To actually print the value of a tensor, you have to call tensor.print to get the inner values of it. Okay, so that's one thing that you might want to try to remember. Okay, let's create a 2D tensor or matrix using tensor 2D function. What you need to pass to this function is actually a 2-dimensional array. So that's what we're going to do. And if you print the shape of this tensor, you're going to see that it has 2 rows and 3 columns. Okay, and again, if we want to get the values of it, you're going to use the print method on the tensor object. Okay, but you might be asking yourself, can tensors only contain numbers? Not necessarily, but in practice you almost always use numbers in them, like most often than not floats. Okay, but just for the sake of it, we're going to create a tensor with strings, just like that, and again we can take the shape of it. Okay, so we have one row, we have a vector, so it's just dimension. We have only one dimension with two values, and again we can print the value of it. As you can see, we have hello world in here. Okay, so the next thing that I want to show you are some utility functions that we are going to use during our modeling. I'm going to start with once. This one will create a tensor with dimensions 3 and 3. So it's going to create a matrix with 3 values and 3 columns, and all values are going to be ones, of course, and as you can see, that's the result of it. Okay, so next thing you can do, and we will actually often do this operation, is to create a tensor or get a tensor from somewhere. And sometimes that tensor is not in the right shape. So what we can do is actually call reshape to turn that vector into a matrix. So I'm going to turn it into a matrix with 2 rows and 3 columns and print the value of it. And as you can see, we have two rows and 3 columns. So reshape does this for us. Okay, the next thing you can do is actually do some basic mathematical operations like add, subtract, multiply, etc. Okay, let's create 2 tensors. The first we're gonna call it A with values 1, 2, 3, and the next one we'll call it B with values 4, 5, 6. Then what we're going to do is add tensor A to tensor B, and this is the result. As you can see, actually this operation, what this operation does, and another thing you can try is actually while you're typing, you can get the documentation for this operation, although actually this example is not that good. But if you write like something like this, you can see the documentation, even though right now there is some bug with the opacity of this window. I don't know why, whatever. Okay, so we're adding A to B and printing the result. As you can see, we have element by element addition. So we have 5, 7, 9, and this is the result that we're getting. Okay, so that was add. Let's have a look at another operation, and that operation is actually applying a dot product to 2 matrices. And I'm going to go to the API and search for dot to see the documentation of it. And as you can see, it computes the dot product of 2 matrices on and or vectors. Okay, so let's give this a try. let's create two 2D tensors, which are going to be our matrices. Okay, I'm gonna take that, create another one with values of 3 and 4. So what we have here is D1 and D2, 2 rows, 2 columns, 1, 2, 1, 2, 3, 4, 3, 4. Okay, so if I call the dot method on D1 and print the result, you can see that we are getting a dot product of those two matrices. And if you want to have a look at what is actually the dot product, there is a really cool tutorial that's easy to follow on Matty's phone. And as you can see that the dot product is actually multiplication of all elements in row by column. Okay, so you can take a look at that if you don't know actually what the dot product is, two matrices. Okay, the last operation that I find really useful when creating tensors is the transpose operation. Many of you might already know what it does, but here is a little example of it. I'm going to create another simple tensor. It's going to be 2D, and if we print its value, we're going to get 2D matrix with the first row 1, 2 and second row 3, 4. Okay, if we call the transpose method, okay, so that might not be so easy to follow, so I'll do that. Okay, so we have 1, 2, 3, 4, and then we have 1, 3, 2, 4. What has happened is actually we did a transpose which actually flipped the columns and the rows in our matrix. Note that this operation can be done on higher dimensions too, but it's not like so easy to understand. So when we have matrices, is actually pretty easy to get. Okay, so after this one is complete, we're going to actually install a new library, and I'm going to show you how to use this rather new library to visualize some data right in your browser. This new library is called tfjs-vis. I know it's a great name, and it's a package available on GitHub that is actually part of the TensorFlow on the TensorFlow stack. It's like rather new, but it's pretty stable already. And you can have a look at GitHub to get a feel of it, but I'm going to show you the basics of it. Like right now, I'm going to install the library. Again, it's tfjs-vis, and after it is done installing and transpiling the modules, I'm going to import it. Okay, like so. And I'm going to actually create a new method called render bar chart. A new function, render bar chart, in which I'm going to create some sample data for our bar chart. The bar chart expects an array of objects with index and values for each object. So I'm going to just put Geo and a value of 10. I'm going to get that and call the next one Jane, and the third one is going to be Ivan, of course. is going to be at 30. The next thing that you need actually is a place to put your bar chart or your chart in general. And one thing that tfjs-vis is offering is like those surfaces that you can use to add your charts, but that's like pretty dumb thing, at least for me. So what we're going to do is actually create a div element in our HTML file, which is this one right here. And this div element, we're going to give some ID, and I'm going to call it bar chart cont from container. So this is going to be our container for the bar chart. I think that's really useful when building real apps to like place exactly and style the position of the div element compared to the surfaces that tfjs-vis is providing. So let's do that. Okay, after we have the data, we're going to create a container or get a reference to our container. We're going to get the element from our DOM tree, and again we're going to use the div ID that we just created. To actually render the bar chart itself, we're going to call tfvis.render bar chart. We're going to pass as a first parameter the container, and the second parameter is going to be the data, and that should do the trick actually. If we call render bar chart from here, as you can see, even though my dumb head is like right over here, as you can see, we have a bar chart. Let me Okay, we have a bar chart over here that is showing the three values that we have. You can additionally style this chart. Let's say you have an X label, and that's the customer name. Then you have Y label, and that's the payment that this customer has provided. You can also provide a height in pixels for this chart. And for example, you can increase the font size if you can't see what it's printed out over here. So as you can see, the chart is now looking a bit better. Okay, and that's how you create a bar chart using tf-vis. Okay, or tfjs-vis, whatever. Okay. In the tutorial that is going to be like right below, including the source code, you can have a look at how to create a histogram and a scatter plot. But for now, I'm going to just go to the creation of a simple model using TensorFlow.js. For that purpose, I'm going to actually write another function. And that function is going to be, I'm going to clear out all of this actually, to just leave a space. That function name is going to be kg2 pounds, and that function is going to take a single parameter known as kg, and it's going to convert kilograms to pounds. As you may already know, pound is a kilogram is roughly 2.2 pounds. So what we're going to build right now is a simple model, like really simple model that tries to predict, but not calculate, but predict the number of pounds given a number of kilograms. So we're going to actually create an estimator, or try to estimate actually this function. And as you can see, this function has a single parameter, and that's the number 2.2. So actually our model will try to estimate this parameter 2.2. And we're going to see how good actually our model is after training it with some data. Okay, let's begin. The first thing I'm going to create is actually the data itself. We're going to create 2000 training examples. And the training examples are going to be in the form of kilograms, and what does this value correspond in pounds. So let's create an array of 2000 elements, and this array is going to be passed I'm sorry, this array is going to be passed as a tensor. Okay, so we're going to use array.from. We're going to create 2000 elements, and that's pretty much it. If I print out the shape of the tensor, you're going to see that we have a one-dimensional vector of 2000 elements, where I'm going to copy all of this, create y's. So our x's are going to be the features that we're going to use to predict the y's, and the y's are going to be actually our pound values corresponding to the kgs. So if I go over here and print out the shape of the y's, I'm expecting the same thing, yes, a vector of 2000 elements. Okay, so we have kilograms as the features that we're going to use to train our model, and the corresponding pounds as labels for our supervised learning model. So the first thing I'm going to create is the model itself, and I'm going to call tf.sequential, and the documentation says that it creates a model, and it's a sequential model is any model where the outputs of one layer are the inputs to the next layer. But actually we're going to create a really simple model which has only one layer, and you don't need to know what this means for now, but it's a bit related to creating neural networks. But for now we're going to stick with a really simple model with one parameter that we're going to estimate actually this value 2.2. Okay, so we have a model, and to that model we're going to add a layer, or we're going to create the thing that is going to estimate this value, the parameter, and we're going to use tflayers.dense. Again, you don't need to know what dense means in this context for now. We're going to put units 1. What this means is that we want our model to have a single parameter that is going to be learned during the training when we use our data. And another thing that we want to give to this dense thing is the number of elements for our features that we're going to use. Remember that the features are actually kgs or kilograms, so the input shape is going to be 1. If you had like something like weight and height of a person, and you wanted to predict their age or something like that, then you'd have to put 2 in here and train the model that way. Okay, so after we have our model, we're gonna call another method on it, and it's called compile. So this is like something that's a bit related to the original Keras API, and I think it's like pretty bad because you have to Actually, to train your model, you have to create it, then call compile, then call fit, and then predict. And it's just another method that you have to remember to call before actually building your model. So what we're going to pass in here is our error function. And our error function is a function that evaluates how good our model is doing during training, during learning these parameters that we're looking for. And we're going to use mean squared error as our error. Again, you don't have to know what exactly this is it, but if we go to Wikipedia and look at the definition of mean squared error, you can see that it's just the average value of the real value. So think the real pounds corresponding to a kilogram and the predicted value of our model, the difference of those two, and we just take the we just square that so that our values are always positive. We take the sum of that and divide that sum by the number of training examples that we have. Okay, so nothing too strange over here. And we're going to create an optimizer, and I'm going to pass Adam. The optimizer, roughly speaking, is the thing that is going to create to get the current error of our model, again using mean squared error, and try to find out another parameter, this unit, that is more closely matching the 2.2 parameter that over here. Okay, and we are going to use Adam as an optimizer. And there is a really good paper that actually introduces Adam from 2014, and you can have a look at it. Adam is a really simple optimizer that works really well in practice. Okay, so now that we've compiled our model, we're actually use the data that we've created to let me just write this down. Okay, we're going to call the fit method on the model object. We're going to pass our data, and we're going to tell it for how long we would like our model to train, and that parameter is called epochs. The number of epochs is actually the number of times that our model is going to see over all of our training data. So our model is going to see our data for 1,100 times. And another parameter that we're going to pass is the shuffle true. Why we need to shuffle our data? Because we don't want our model to remember any temporal relations. What this means is we don't want our model to remember first what 1 kg in pounds is, then 2, then 3, then 4, then 5. We want it to remember at random whatever the kg is put into it to output a value that is predicted to be correct. So we don't want any relationship within the data itself. Okay, so now that we've trained our model, I'm going to actually print out something that tells us if we're really training, and then when it's all done, okay, this seems a bit slow. Let me just refresh the page, because I don't really know how many times this script has started. Okay, we have a training that has started. A warning that tfjs-vis is not used, which is alright. And our model is still training. That's a bit strange. Oh, it's done. Okay, so this should be working. And now that our model is trained, let me just even though autosave is disabled, this is re-rendering every time I type something, which is strange. I might have a look at it. Whatever. Okay, so now that our model is actually trained, we're going to force it, not force it, but we're going to ask it for a prediction. So let's predict the value of the value of 10 kgs into pounds. We're gonna take the number as a scalar value, and then we're going to call data sync, which will actually get the tensor values and convert them into a JavaScript array. And finally, we're going to print the result. Okay, and again I'm going to refresh, wait for it to finish. Okay, so the model is training. Code sandbox is really slow. I might try to do all of this on my PC next time. Again, the source code and additional explanations will be available on the link below this video, and the link to the sandbox is going to be in here as well. So as you can see, our model has predicted that 10 kgs are actually 23.6, which is like quite, well, it's not correct. Of course, it's going to be 22.2 kilograms, but it's something that shows you that maybe, just maybe, our model is learning something. And just to check it out, I'm going to actually make a prediction of the model before training it, just for the fun of it. Before training, since our model is like training pretty fast. So I'm going to call this untrained, and this is going to be trained. All right, refresh again. This refresh thing might be kind of dumb, but I'm not happy with this setup. I might try something else for the next video. Okay. So our untrained model predicts that 10 kgs are actually 0.75 pounds, which is horribly wrong. And after training, we're going to wait and see again what our model is going to predict. Okay, this time the prediction is a bit worse, but still, after training you can see that the prediction is infinitely better. So this is how you create a very simple model in TensorFlow.js. Train it in your browser. Use tfjs-vis to create some basic charts. And the next time I'm going to show you how to actually predict whether or not a person has diabetes based on a simple, on a small data set that we have, that is provided by some medical institute or something like that. And next time we're going to actually have a look at the training process using tfjs-vis and see and evaluate how our model is doing during training, and eventually create a model that is pretty accurate at predicting whether or not a person has a diabetes based on the data that we have. So that's pretty much it. Please like and subscribe to the channel. Thank you very much for watching. Bye bye.